All right, we're ready for chapter 11, which is tactical ventilation. We're going to talk about tactical ventilation, basically how we perform this during the bread and butter operations of a structure fire. So why do we ventilate? What's the reason for a planned ventilation? And basically, this is a planned out, systematic, coordinated removal of heated air, smoke, and gases, or other airborne contaminants from the structure. This is used to control fire growth and fire spread. The big thing is to evacuate smoke during overhaul and loss control. And we want to control where the hot gases and the smoke is exhausted out. Controlling oxygen availability. If a fire consumes available oxygen, it then enters a ventilation limited or a decay state. Any ventilation will add oxygen and then allow the fire to grow. So it's important that we understand you have to have three things: heat, fuel, and oxygen. We're using fuel and oxygen during the process, and it's producing those heated toxic gases and unburned hydrocarbons, or those small particles in carbon particles in smoke. Controlling the flow path. Keeping exterior doors closed until a charged hose line is ready and in place is one of the practices now that has become common. And basically we're keeping we're limiting the amount of oxygen that can get to the fire, and completing that path can ignite rapid fire growth, especially in a ventilation limited situation where the heat is there is superheated gases at the ceiling level, there's smoke particles, which we know smoke particles are fuel. They're readily able to ignite at these higher temperatures. We want to keep that control path and that flow limited. We can control the flow by performing vertical ventilation, and that's a pre-planned and timed coordinated effort, as you will, that we can cut a 4x4 or larger hole and right over the seat of the fire preferably, and exhaust those heated gases and smoke out the ventilation hole. Positioning firefighters too close doors along the way of the entry path as well. We can control the flow path, and then ventilation and firefighting must be coordinated. So everything to do with ventilation should be coordinated, and that's so that we don't catch our firefighters in a flow path, and then we add a lot of oxygen or air into it and allow those ignitable gases to light up. A word of caution here is breaking windows unnecessarily or freelancing disrupts the ventilation strategy, which in turn loses control of the fire. And there's been plenty of case studies that we've looked at, that you will look at in the survival and rescue program, where, for an example, a sliding glass door was busted out, the glass of it is gone, and then it caused a rapid fire growth because the flow path was then completed. And so these are the coordinated things that we were talking about. Everything, communication has to take place. Everything has to be coordinated when it comes to ventilation. We can close openings. We can cover openings as well. One thing that we need to remember about glass is that once you break it out, you do not get it back. So this window here was probably broken out during the process. Now they're having to cover it, and this doesn't work very well, because you're going to have hot gases and smoke trying to come out of the top part of the window, or that opening, just like you see here in the door. And it's going to be pretty tough to hold that up, a salvage cover or something up there the entire time while you're trying to chase down the seat of the fire and get it extinguished. Rapid growth. we know that fire doubles nearly every minute or so that it'll double. Growing fires can become untenable for the occupants if there are folks trapped inside, and it can be untenable at a point for us with our full PPE on within minutes. And so, by inadvertently breaking out glass, for an example, window, and creating some ventilation, we think in theory we're doing good for the situation, but then we realize we completed the path and we let a lot more air in, and it lit up everything from one spot to the other, from one opening to the other. The potential for rapid fire development: air from ventilation is introduced. These heated gases that are already hot enough to ignite, they just need the oxidizer in the equation, heat up and reignite. And then as that chain reaction occurs, you can find yourself quickly in a situation where rapid fire development has occurred. So how do we take care of this? Two things: cool the superheated gases with an appropriate amount and application of water. And another way is to release the gases with an appropriate type of ventilation. These two things, and even together, can prevent rapid fire development. Ventilation without coordination can and will lead to flashover. Additional ventilation alone will allow for fire to grow and not prevent flashover. The longer the compartment is allowed to ventilate without water being applied, the sooner that flashover will occur. So basically you've got air coming in, but you don't have enough heat exhausting out as necessary. You get radiation feedback within that room, and at some point there's going to come a time where it reaches the ignition temperature of everything in the room, and then boom, it's going to flash over. The initial effectiveness is likely to be short-lived, so when we do cut those holes, our goal is to do it near the same time or close to the same time that water's being applied to the seat of the fire. This will exhaust out the heat and the gases and the smoke, and it will and the steam as well when the steam conversion occurs through application of water. And this should make the environment better overall for the firefighters and any tenants that are still inside. Additional oxygen allows fire to grow, and it will allow it to grow over that curve to flash over. Ventilation needs to be coordinated with your fire attack almost immediately. This is something that really needs to be thought of and coordinated by the incident commander, and then the two teams doing the job, the attack team and the ventilation team, need to coordinate with one another as well over the radio. Ventilation alone decreases fire spread. It increases visibility for short periods of time. The ventilation and water application are both necessary to bring a fire under control. Once water is applied to it, ventilation can improve the conditions on the inside. So it's important to us. We want to remove hot gases and we want to remove smoke at the same time that we're approaching the seat of the fire and we're ready to put water on it. The heated gases become less dense and they escape to the areas of the lower pressure. As hot gases escape, they create a lower pressure that then will draw in cooler ambient air. So if you think about leaving the front door open, or the door that we're going through, you have basically heated gases going out the top portion of that opening, but you can watch the smoke and you can see it move towards the seat of the fire where we've completed that path, that flow path, and we have air, cooler air from the bottom of the opening going in. Uncoordinated ventilation can move heat and smoke to uninvolved areas, and that's something that we really don't desire. And so this is an example again of we leave a door open, we're unprepared, we haven't controlled it, and we can allow fire to rapidly spread into other areas. I mean, it makes putting out the seat of the fire a lot harder. With our ventilation openings, we now know that they can remove less heat and smoke than previously thought. It does alter the flow path, and it introduces air, which can alter the fire's development, and it can also intensify the growth, as we've discussed. Have to be made to allow smoke, heat, and toxic gases escape. So we have to have them big enough to allow these gases and smoke and heat to escape. Application of water should be coordinated with ventilation. This can minimize the effect of new air on the fire growth and transitions the fire from ventilation limited to a fuel limited situation. Tactical ventilation can create more tenable conditions. The increased oxygen concentration, a reduced concentration of toxic products of combustion, and then a reduced temperature, overall increased visibility. One thing to note here is once a structure fire has become ventilation limited, additional ventilation will cause fire growth and spread. And what we need to understand is this could cause rapid fire growth. Application of ventilation for life safety. A coordinated tactical ventilation can alter the flow path away and create tenable egress areas. So again, we want to coordinate where we place our openings. Typically, we would place an opening over the seat of the fire or near it because that's where the gases are the hottest, and that's where we're wanting to exhaust that. Doing this correctly and coordinated can mean that we are making a situation better ahead of that seat of the fire. Interior fire attack and search and rescue operations. Ventilation, this create areas for firefighters can move and work. The ventilation should be organized to prevent fire from spreading. That's one of our goals. We want to keep fire ventilation limited as long as possible to prevent that spread, and then search and rescue should be delayed until lines are charged and crews are ready to go. Again, coordinated ventilation. All teams should be ready to go before we initiate the ventilation operations. This will help control the amount of oxygen allowed into the structure. The crews should communicate observations to the incident commander and any of the exterior crews. They let them know, is it getting better, not getting better, is it getting hotter? Complete rescue without increasing the hazard, harming entry firefighters, spreading the fire, or allowing the fire to enter rapid fire development. Ventilation applications during overhaul. This can accelerate clearing of smoke and hot gases and minimizes smoke damage and property damage. Not uncommon to start positive pressure ventilation, which is fans blowing in as we open some horizontal openings such as windows, and we can channel our smoke removal by opening and closing doors in rooms to clear them out. And this is basically when we have the main fire put out, we're hitting hot spots and we're trying to get smoke and carbon monoxide out of the structure. Next is the safety considerations related to tactical ventilation. Successful tactical ventilation conducted in conjunction with fire attack depends on some things. One that we've talked about is careful planning. This has to be a planned effort. Communication of observations to the incident commander. How are things changing? Are they getting better? Are they getting worse? Systematic application of procedures. Everybody has to be ready, coordinated at the same time. Coordinate with your fireground activities. Those officers that are in charge, or firefighters that are in charge of each group, communicate well with one another as the coordination of the efforts go. And then recognition that all openings are ventilation. A door open, even a little bit, is a form of ventilation, and we control them as best we can. Recognition of advantages and disadvantages of environmental conditions at the scene. Situational awareness with tactical ventilation. The conditions that should be communicated to crew members and supervisors. One is the location and the extent of the fire. Once we know this, communicate this. Changes to fire behavior any changes in fire spread or growth, including signs of rapid fire development. Effect that ventilation at a location will have on the fire and or exposures. We want to keep an awareness for effectiveness of planned ventilation, the desired flow, and the exhaust efficiency. Are things working? Is it getting better? Location where smoke is escaping, reading smoke, looking at your smoke color, velocity, how it's coming out, where it's coming out, and look at that with your building construction. What kind of building are you looking at? Type 1, 2, 3, 4, 5. The building structural integrity itself. Conditions of the building content should be communicated. Any indications of potential structural collapse, especially roofs and floors. Keep an awareness of this during these type operations. Locations of overhead power lines, solar panels, and guide wires. We communicate the locations of 2 escape locations for the roof, those that are on the roof if we're using or doing vertical ventilation. Any changes to the roof or floor structure integrity, and the coordination of fireground operations with ventilation. Wind direction and strength, it makes a difference. You can get into a situation where we have a wind-driven fire where the fire is basically being fed with the wind creating more air being forced in. Any opening at that point, even a small opening with a door with a hose line going through it, can make a difference. Unplanned ventilation and the integrity of your structure. When failure of the windows and doors happen, and structural members as a result of heat and fire exposure. So we talked about taking out windows ourselves unplanned and how that can be, a problem for us. Also, when the fire itself self-ventilates, when it heats up enough to take glass out or a window, when it heats up enough to burn through a door, or when it literally burns through the roof, and it has vented itself. So any of these unplanned ventilation can significantly influence the fire behavior. It can complete flow paths, it can add a lot of oxygen to the fire, and it can cause rapid fire growth. The assumptions about any structure fire to guide decisions about ventilation is the structure consists of lightweight construction. We can assume that these are going to, they're going to be untenable pretty quickly. It's hard to put a time frame on when collapse will happen, and so we have to read and look at everything involved, from the seat of the fire, where it's at, the amount of fire, and how long it's been burning. And then, is the fire ventilation limited or not? Wind conditions we hit on just a little bit a minute ago, but any opening allows the surrounding atmosphere to affect what is happening inside. As firefighters, we should use the wind to our advantage during ventilation. Winds as slow as 10 miles an hour can affect structure fires. Firefighters are safest working with wind to our backs. Exposures is something that we have to think about. And remember that there are 2 types of exposures. There are external exposures, which when we say exposure, that's typically what we think of the most. We worry about embers moving over to neighboring structures and vegetation and catching it on fire. Radiative heat also can heat up the outside coverings of a structure, adjacent structure, and heat it up enough to cause combustion. And then we also have internal exposure. So we have the seat of the fire in a compartment, but you have rooms in proximity of where the seat of the fire is. So these are all would be considered internal exposures. We need to gather as much information as possible about the fire, the building itself, and the occupancy before we ventilate. And so we need to be cognizant of where to ventilate. Typically that's close to the seat of the fire or over the seat of the fire, if at all possible. We're responsible for communicating observations about performing ventilation. Integrity of our roofs. This is something that we don't put firefighters on roofs as often now as we used to, but we need to know some things. Prior knowledge of the roof's construction and building layout can help you gauge the integrity of the roof. Is it stick built? Is it truss? This information can be gained through pre-incident planning. Sometimes you can look at an outside of the structure and tell. Sometimes the homeowner may know what type of roof has been installed. Structural elements that may contribute to roof failure during a fire. One is lightweight truss roofs. Though, when they're very strong, but when they're put together with gusset plates, that when everything is in place, it's good, but when you start getting the deterioration up against those joints, then you start to weaken it, and it's a domino effect. When you weaken a part of a truss, you begin to weaken the whole truss. When that truss goes, you begin to weaken the system, and it can be a very rapid domino effect as well. Open floor plans under wide expanses with limited truss supporting, where you have, these days they put LVLs, the laminated beams in these areas. Those are put together with glue and plywood, and when the glue burns, it burns pretty rapid and hot, and you lose your integrity, and that can set you up for potential rapid collapse. And then any prior damage to the structure as well. Some model building codes require placarding or signage on structures to indicate the presence of lightweight construction, most notably floor and roof systems. And our commercial properties here in Frankfort do. We do require that a sticker is placed at the entry doors. It's just a red T, a white sticker with a red T, and it's a circular sticker. And so when you go to enter that, you look down and you see that, you know that it's got a trussed roof. The integrity of your roof. If the roof is expected or known to be unstable, then the incident commander should not place personnel underneath it. It makes sense, common sense. If ventilation is ordered, check the roof before stepping out onto it, and continue checking across it as you go. If fire has vented through the roof or has been burning under it, ventilation should not be considered until the fire has been suppressed and the roof structure can be evaluated. So if it's self-vented, it's a concern. Indications of possible roof collapse: melting asphalt on flat roofs and even peaked roofs. When you see the shingles are melting, smoke or fire coming from the roof itself, any sagging or leaning of the building systems. If you look across the roof and you see sagging, this could be possible set up for collapse. And any sponginess. When you check the roof, when you push up against it with a pike pole as you go, or you step and you sound it as you go, and it's spongy, then it's there's a lot of damage underneath. It's time to retreat. Some roofs are spongy with no fire involvement. We have to know the roof types and the systems in the response area and understand that. So especially on commercial properties, when we go and we do these building inspections and we do pre-plans, we need to get on the roofs and check things out. The ventilation team should communicate with the other crews. The roof loses integrity during roof ventilation, so it does. We're cutting a hole in it, and even though we don't cut support members themselves, we can weaken it. Evacuate the roof and notify command if we lose integrity of that roof. And the reason why that we want to ladder to different sides of a roof or a building when we put people on the roof to ventilate is so if it were to weaken and lose integrity in the pathway that we took, and we can't go back that way, then we need an alternate way of egress. Next is the ventilation tools and ventilation equipment. Tools and equipment, we'll talk about what we use to perform ventilation, the create openings. They're used to create openings rather, where gases and smoke will exit the structure. We use our tools to assist in moving gases and smoke more efficiently and to help access ventilation locations. We monitor and identify ventilation locations. So some of the tools that we use to create our openings. First on our list is the good old fire axe, preferably an 8-pound axe or an axe with an 8-pound head is going to cut better. We also often use power saws or the rotary saw and or chainsaws. And then we're going to need with us a pike pole to remove decking material, but the biggest thing is to move the gypsum, sheetrock, or plaster and lath that's going to be underneath your roof where your ceilings are. We have to knock that out to get everything to exhaust out. Equipment that's used for moving air. These devices, such as fans, we may use flexible duct as well. Vent fans or positive pressure fans, as we call them, both gasoline and electric operated. These are the primary control devices. You can stack and hang and use them in tandem. One thing with the electrical equipment is we need generators and electrical cords for that to work. So we're using generators and we're going to use cords and our plugs and pigtails, and wind control devices as well, and smoke control devices. Positive pressure fan here is typically what we carry. It's gasoline operated, and what we have to realize with this piece of equipment is it's designed to run on gasoline operated internal combustion engine, so it does produce carbon monoxide and it is blowing that exhaust in. So there comes a point when we either want to use electric or we want to change this over to electric and get the rest of the carbon monoxide out as well. The next one is a smoke ejector. This is primarily used to remove smoke. It's a not as high velocity type fan. Typically you don't see these carried anymore. You do see the positive pressure fans carried, and most of those are gasoline, but we are starting to use electric positive pressure ventilation fans now, and because they don't produce carbon monoxide. You can use a hose line and a nozzle on a full fog to ventilate out a window or out a door as well. It will draw air as it passes or spins the ring in the nozzle. And we have to have, in most cases, especially if we're using electrical equipment, generators and cords. Inspection and maintenance of our ventilation equipment is pretty much across the board. It's standard as we do most of our equipment. We'll do a routine inspection and maintenance, and it depends on the equipment. These could be weekly, monthly checks. A lot of times we will start generators and we will check things. Saws, we will start saws daily. If you're working with a volunteer department, that's probably weekly for the most part. We want to follow manufacturer's instructions on how to maintain and what type of fuels they use if they're gasoline operated, and we want to document our inspection, whether that's daily, weekly, or monthly. Equipment that fails inspection should be marked out of service. Let an officer know in the chain of command and take it out of service so it can be repaired. The authority having jurisdiction should establish inspection and maintenance standard operating procedures. Next, we'll talk about horizontal ventilation. This is one form of the ventilation that we use probably most often, I would say. And most of the time, we try to do this in a natural way. Natural ventilation. We'll open up windows, let things passively ventilate. If we're under we're still under operations and we haven't completely controlled the fire, we may move to positive pressure ventilation by mechanical means. We don't use hydraulic ventilation as often. Usually it's a temporary thing. We use it briefly to clear a room, and then we'll move to natural or mechanical ventilation. Natural ventilation should take advantage of the natural airflow by opening doors, windows, and so forth. No additional personnel or equipment are required to set it up, and you can use the wind and wind direction to your advantage in this situation. So with wind assisted ventilation, we can use the wind to our advantage. We want to open up, openings on the upwind side, usually windows, and open up on the outlet side. And all the while we coordinate at the same time for fire attack. And this can certainly be an advantage to us. We just need to make sure that we coordinate it and we get things done in a timely manner. One thing to remember about taking out windows, once you remove glass, by physically removing it or destroying it, we don't get it back. And so sometimes it's just as easy to try that window before we bust it out and see if it'll raise, and we can open it that way. This type of ventilation during or before fire suppression, if only a single opening is made, it will be the intake and the exhaust. So remember that it will exhaust out heated air from the top of that opening, and it will draw in the cooler air from the bottom. Opening windows or doors may allow firefighters to apply straight stream from the exterior to make the compartment more tenable for interior attack. This is called resetting the fire in our slicers program. Door control can be used to change the flow path. So we want to control it, and we want to keep from completing that flow path if possible. Control natural ventilation as much as possible. After fire suppression, multiple openings can speed up the removal of smoke, and it could result in property damage as well. So we want to make sure that we do get things opened up, we remove smoke, but make sure that we coordinate it by opening doors on the inside to keep smoke out of ineffective areas and to get the rest of it out of the building. Mechanical horizontal ventilation may be necessary when the natural flow is not sufficient enough. This is where we bring in our fans and blowers, and we create that positive pressure. You can use smoke ejectors to create a negative pressure. That's the way they are designed. Most fire departments aren't carrying them or using them anymore. Do not upset the effects of horizontal ventilation. This can be horizontal or vertical, but most commonly horizontal. Most of the time we're able to open up doors and windows and allow our mechanical ventilation to happen horizontally. Again, this must be coordinated with other tactics. Positive pressure in, artificially raising the pressure inside, so smoke and gases will move towards that lower pressure, which is the openings. In a negative pressure setting, we are artificially lowering the pressure inside, so fresh air moves in more quickly. Mechanical horizontal ventilation can accelerate the exchange of fresh air. That's kind of our goal. We can do harm if the fire is not under control. So again, we can pressurize, we can feed the fire with a lot of oxygen, if you will. So again, everything has to be coordinated. This adds air to the structure a lot more quickly than the natural ventilation would. If used to create visibility and flow path for interior operations, all equipment must be in place and all your crews must be ready before ventilating. Limitations of mechanical ventilation will depend on the source of power. It may require special equipment and require more additional resources and personnel than natural ventilation. So we know that gasoline vent fans will put in carbon monoxide because they're drawing in the exhaust through the fan itself, and so that can be a limitation. It does require, electric requires cords and generators and other equipment and personnel to put in play. Never direct a fog stream into a horizontal exhaust opening when interior attack crews are inside the structure, because it will force smoke, heat, and steam towards them. After fire suppression, contaminated atmospheres must be cleared quickly and thoroughly. Confined spaces with low oxygen levels can benefit from fresh air. Ultimately, we want to reduce the smoke damage done, and then we want to improve relations with home and business owners. So we want to coordinate it to where we're not doing more damage, but we're doing less damage. Mechanical ventilation, again, is most effective. Gas-powered fans, as we have stated, can add carbon monoxide to the structure. Ventilation after suppression should lower carbon monoxide levels. So during this process, we must wear our SCBA and then monitor the environment until we have confirmation that the atmosphere is safe. I'll always be an advocate to wear your gear, wear your SCBA breathing air during overhaul operations. Again, gas-powered fans may add carbon monoxide to the mix during these operations. Wear your SCBA until you're confirmed that the gas levels are below the required limit. Advantages of mechanical ventilation to clear contaminated atmospheres. This supplements and enhances natural ventilation. It ensures there's more control of the airflow itself, and it speeds the removal of contaminants. Reduces smoke damage if we coordinate and open door and close doors correctly, and it promotes good public relations. Negative pressure ventilation, again, is not used as often nowadays as it has been in the past, but some still use it, and this is using smoke ejectors. Smoke or hot gases are drawn out, and fresh air is drawn in. This does require electricity. These are electric fans that they're using. Opening around the fan must be sealed, as you see here in the photograph. Not as effective as other forms of ventilation for removing smoke. Safety guidelines for smoke ejectors. Keep the intake side free of obstructions. Turn off when moving them around, of course. Carry using the handles. Ensure that people clothing curtains or draperies are removed or secured before starting the fan, and then avoid standing in the outlet area. What we know most is positive pressure attack or ventilation, and this works best on compartment fires. High volume fans used to create higher pressure in adjacent compartments and force smoke through the exhaust openings. The fans must create enough pressure to do so. If the pressure is not sufficient, smoke will exhaust through the intake. Controlling flow within the structure before suppression, if correctly done, this will reduce the thermal effect as firefighters perform interior operations. If this is incorrectly done, the potential for rapid fire development, as we've talked about, is there and can spread surges. Intake, exhaust. This is pretty simple, and you create this cone right here. So you want to set your fan back far enough to create that cone. Basically, you're wanting to encompass this entire opening, and then that will pressurize the unpressurized compartments, and then our goal will be for it to come out the exhaust. This is a interior diagram explaining what our goal is. So again, the intake, we want set your fan back far enough to create the cone here with this opening. and we want to exhaust it out and make things more tenable. Here's some effective and ineffective examples. In the effective side, we can clearly see that we're exhausting out. We have one end. Here, if we don't open up and close doors correctly, we can channel in areas that we don't want. So we can pressurize and put smoke into areas that we don't desire. Our goal would be to come out here and here. And so we have to be able to think about it, open and close doors accordingly to meet our goal. So this means coordination is required. Changes to flow path may cause rapid fire development. Inside crews can become trapped as well. That's a really good reason why we need to coordinate things. Search and rescue operations have high potential to change the flow if crews open and close doors. Enter and exit from the intake only. Do not block the intake and only search open compartments. Application of water reduces pressure differences, making PPA more effective. Temperatures reduced along the path of approach as well. We apply water to the fire compartment as soon as streams will reach it. So crawling right up into it is not really the thing. You can, if you got an open door and you can see the glow, you can hit it from the hallway or from the outside of that room as you approach. High volume fans are used to exhaust smoke, heat, and toxic gases after suppression. The higher pressure, again in the building, moves smoke towards the lower exhaust side. Less emphasis on exhaust to intake ratio. The goal here is to increase pressure to higher than the exterior, not higher than the fire can produce. And basically the same concept as in PPA. We have our cone encompassing everything that we can get, and we have the appropriate exhaust, and we channel that within to exhaust out the correct area and not damaging undamaged areas. The sooner positive pressure ventilation begins after suppression, the more effective that it is. Again, it's more effective at decreasing the temperatures, decrease toxic gas concentrations, and it increases our visibility. This may also hide fire extension while the fans are running. Oftentimes we will shut fans down and you'll begin to see some smoke and steam and smoldering, and that helps clue us in on some of these hidden fires during overhaul. Smoldering fires can intensify with the additional airflow. This can, once we open something up and enough air gets to it, it can also, kick up the fire. It gets enough oxygen to flame up during overhaul. Identify and control your fire extension. Use your thermal imaging cameras. Once conditions improve, shutting off the fan or closing the intake can allow interior crews then to evaluate the conditions. We should ensure that exhaust surface exceeds the intake area with positive pressure ventilation. Monitor your fan operation. Maintain communications with the incident commander, interior crews, and whoever's operating the fan. And take advantage of wind conditions as well. So advantages: firefighters can set up fans that are blowing in without entering smoke-filled environments. You're doing this from the outside. It's equally effective with horizontal or vertical ventilation. The removal of smoke and heat is more efficient, and the exposed buildings or adjacent compartments can be pressurized to reduce the spread of fire. Some disadvantages to it: the structure must have remaining compartmentation. Exhaust from your gas-powered fans can add carbon monoxide to a structure, and then hidden fires may be accelerated and spread. PPV in commercial and multi-story buildings, we can use multiple fans and we can tandem fans at the bottom, and you notice that we're getting, the cone each time. And so you can strategically place your fans to exhaust smoke out. Again, if they're gasoline powered, we're adding carbon monoxide inside the structure. If they're electrical powered, it takes more time and effort to set them up. Hydraulic ventilation may be used where other types of forced ventilation are unavailable to us. It can be used to clear a room or building of smoke, heat, steam, and gases after the fire has been controlled. And this is usually when we're doing it. Typically, we're doing it to clear a room. It uses a spray stream from the fog nozzle to basically entrain the smoke and gases and carry them out of the structure. And usually we'll do this close to a window or an opening, and we're spraying out. This requires firefighters to operate the nozzle in a contaminated atmosphere. White fog pattern to cover the exhaust opening, and the smoke is drawn or pulled out. If you've operated a fog nozzle at 45 degrees or greater and you put your face close to it, you can hear and feel the air moving. Disadvantages of hydraulic ventilation: water damage may increase if done incorrectly. We can put a lot more water into a room that we don't want to put or have any more water damage. It uses water, so we deplete water supply. If water supply is an issue, if we had a tanker shuttle and we're operating off of above ground dump tanks, then that could be an issue. Ice will form on the ground when temperatures are below freezing, and it could make it slick in situations. And firefighters operating the nozzle will remain in heated, hazardous atmospheres. So you have to maintain wearing your SCBA. Next is vertical ventilation. This is where we may have a horizontal inlet, and we have created a hole or an outlet in the roof line, and the smoke's being exhausted out. And the flow path principles are the same. Risks of vertical ventilation: basically, anytime we place personnel above ground level and on roofs, there is an element of risk to that. Working on peaked and flat roofs both have risk to it. Working above the fire itself, you're working above the fire, and working on roofs that may be weakened is risky. Factors that reduce effectiveness of vertical ventilation: improper use of mechanical ventilation. And we've talked about this already, but uncoordinated ventilation most definitely reduces our effectiveness. Fog streams directed into ventilation openings. We don't need to do this. We want the hot gases and fires going to come out. And our goal is to have a attack team ready near the seat of fire to start putting out the fire. Additional openings between attack team and the upper opening can be a factor, and then improper location of the vertical opening itself. Safety precautions when it comes to vertical ventilation: work with the wind at your back or side. This is going to work best. Ensure that the main structure supports do not get cut into. So if we're cutting that 4x4 or bigger hole, when you cut across either your trusses or your rafters, make sure that we don't cut deep down into those boards. Guard the opening to prevent personnel from falling into it. Evacuate promptly when work is complete or when you're ordered to leave. Use lifelines, roof ladders, or other means to prevent personnel from sliding and falling off the roof. It is best to work off of roof ladders. That's what they're designed for. Make sure the roof ladder is firmly secured over the peak before we begin to work from it. Make sure that the hooks are engaged. Exercise caution around electric wires, solar panels, and guide wires. More and more people are using solar panels today, and it is important that we make sure we uh, that we maintain safety with those. They are energized and they do have high voltage. Ensure that all personnel on the roof are wearing their full PPE, including their SCBA. And I see this a lot in photographs of firefighters ventilating a roof vertically, and they have their pack on and they're not wearing their mask and they're not breathing air. And there's smoke all around them. Stay out of range of those who are swinging axes and or operating power saws. Remain aware of overhead obstructions. Be aware of where your service drops, if they're overhead or coming into for the power. Start your power tools on the ground to ensure that they operate, and make sure they are turned off before hoisting or carrying them to the roof. So get them running, let them warm up, shut them down, carry them to the roof, and then we'll restart them. Make sure to cut away from your body, not towards your body. Other safety precautions: extend ground ladders at least 3 rungs above the roof or top of a parapet wall, and then secure the ladder. When operating from aerial platforms, the floor of the platform should be even with or slightly above the level of the roof. Check the roof for structural integrity before stepping onto it, and monitor the roof's integrity throughout the operation. Walk along load-bearing walls and the strongest points of the roof when possible. When the roof has been opened, penetrate ceiling below with your pike pole to enhance ventilation. Remember, roof ladders do not increase firefighter safety on weakened roofs. Never direct a fog stream into a vertical exhaust opening when interior attack crews are inside the structure. It will basically force smoke, heat, and steam down into and towards them. Sounding the roof. You've heard this term. I talked about it a couple times. Before you step off of that ladder, you want to use a tool and sound the roof. This determines if the sheeting is intact. Provides no information about the structural members beneath it, however. If trusses fail before the sheathing, the roof may sound solid but will fail under the weight. So they can still sound solid and fail. Some roofs will not respond to sounding. Sounding the roof does not provide enough information to ensure the roof's integrity. It should not be the only means used to determine the stability of the roof. So we use saws for ventilation. Chainsaws is most common, and we also are geared up to use rotary or circular saws. Responsibility of the roof team is to be in constant communication with your supervisor or the incident commander at all times. Maintain situational awareness and report any changes to the supervisor. As the ventilation team leader, you're responsible to ensure the roof is safe to stand and to walk on. You ensure that only required openings are made. Direct the efforts to minimize secondary damage. Coordinate all team efforts with firefighters inside the building. Ensure safety of all personnel assisting with ventilation operations. Ensure that there are 2 means of egress from the roof. So that means you can see 2 ladders, 2 tips of the ladders on different sides. Ensure that an adequate exhaust opening is sized. So 4x4 might not be big enough. We might need, a 4x8. We might need bigger. Ensure the team leaves the roof as soon as the assignment is complete. Work in groups, at least 2. We do not freelance, but with no more personnel than absolutely necessary to perform the assigned task. In other words, if it only takes 2, we don't need 6. Cutting an inspection hole. provides some information about the location of the fire, presence of fire below the roof where you're at. It could clue us in on some construction features, whether or not we have rafters or trusses or what type of support material is below it. And it can tell us some information about the spread of fire. A kerf cut is simply cutting a slit into the roof and seeing if smoke's coming out. That's primarily what you're doing. A triangle inspection is we cut a triangle, and again we're looking for smoke, fire, and you may even see a little bit inside that triangle cut as to what kind of material that you're dealing with structural wise. Ventilating flat roofs, square or rectangular openings, or louvered type cuts work best. Shingle covered pitch roofs, we want to cut a few inches below the peak. On the downside, always cut near the highest point when possible, and it may be necessary to work from aerial apparatus on extremely steep roofs. Slate or tile covered pitched roofs, the roof covering may be attached to solid sheathing or battens with spaces between them. Remove or smash individual tiles. The ventilation hole is cut in the standard manner if the subroof is solid. It may not be necessary if there is enough space in between the battens. Metal roofs. Thin metal roofs we can cut with axe or carbide tip chainsaw or even a rotary saw, then peel it back. Oftentimes our rotary saw works best. If not, you can use an axe. Thick metal roofs we cut with metal cutting tools or power saws with metal cutting blades. This is where your circular saws come into play. It may be faster to open skylights, monitors, or scuttle hatches on industrial type buildings. Sheet metal roofs may be laid over skip sheathing, cut with power saws, axes, or sheet metal cutters, shears. Skylights. Remember that skylights are not going to support firefighters' weight most likely. Assume that they're not going to. So don't step up on them. Don't sit, lean on them. Identify and avoid designated walking areas. Indicate safe areas for walking. Trench cut, also referred to as trench or strip ventilation. This is where we go the the width of the roof, basically in line with our support material, and we do a louvered cut, and basically you're creating a fire stop. It exhausts us out, and you're able to, if you coordinate it right, you're able to fight the fire there at that point from the inside. Trench cut are used to create defensible line ahead of the fire spread. This is our ultimate goal, is to keep it from spreading any further, and these are usually in large open type buildings located ahead of the advancing fire at a distance based on the fire's growth. It does take multiple firefighters to accomplish this task. Charged hose lines should be present and only create in coordination with other vertical ventilation. 2 parallel cuts that extend from one exterior wall to the opposite exterior wall. The distance between should be large enough to prevent fire from burning past and small enough to not compromise the integrity of the roof. The opening should be 4 or more feet wide and extend the width of the building. Remove the roof material between the cuts and push down the material below. So width of the building between load-bearing walls, at least 4 feet wide, and we want to remove the material below it. Advantages of the trench cut can be used to establish a defensive position in the attic space for structures with a common attic. Works well in large buildings. Some disadvantages: it can be time consuming and physically taxing to achieve. It can place firefighters in dangerous position of working ahead of the fire. If created improperly or at the wrong time, it can cause rapid fire growth and spread. Next is considerations related to ventilation of basements and other special compartments. Basement fires can be difficult to control and deal with. Ventilation must be coordinated with our fire attack. It is important to determine the fire stage before ventilating. Again, we've got to coordinate this with fire attack. Unless vents are installed, heat and smoke will spread quickly upward. So we got to know what kind of basement and what access that we're dealing with. Are we dealing with hoistways? Do we have basement windows? Is it interior stairways, or is the cellar doors the only entrance from the exterior? The methods used are ground level windows or below ground level windows with wells can provide us with horizontal ventilation. A windowless basement, piercing nozzles can be used before ventilation to reduce the risk. Ventilation by stairwells and hoistway shafts as well. We can open these up. Some stairwells in multi-story buildings are pressurized. There are fans and HVAC systems that pressurize this. Cutting a ventilation opening in the floor. This is one of our last resorts. We cut near ground level, near the ground level door window, and the heat and smoke forced from the opening through the exterior using fans. So you're cutting in a hole in the floor near a window so we can exhaust that out the window basically in the floor above the basement. Interior vertical ventilation may be used if other methods are not available or effective. It may require working on fire weakened floors above the fire, which is a risk. Only use when you are sure the floor will support your personnel. Sound the floor before cutting. Floors can fail at any time and without warning. To breach the floor, this may be necessary to ventilate, to apply water, or to rescue occupants. Subfloors are wood or concrete. The variety of coverings on the top of subfloors, you can have carpet, you can have tile, you can have hardwood decking. Tools, methods, and feasibility of opening depends on the type of floor construction. Fires in windowless buildings. Creating ventilation openings may delay the operation for a considerable amount of time. Difficulty ventilating depends on the size, configuration, occupancy, and the construction materials. Usually requires mechanical ventilation. HVAC systems can clear smoke in if they are designed to do so, but are likely to cause more fire spread. This brings us to high-rise fires. More occupants in high-rises, life safety is a higher priority. Ventilation has to be coordinated again. More personnel, much more personnel are required. In high-rises, we can get the stack effect. We know that smoke moves up and out, and as it moves up and out, it begins to do what? When it meets resistance and has no other way to exhaust out than it can bank back down and stack. Tactical ventilation must be considered during pre-incident planning of these buildings. It is very wise if you have multi-story buildings to pre-plan them. Stairwell that penetrates the roof can be used to ventilate, and other stairwell to use as the escape route. Doors must be controlled. Keep your doors and your stairwells closed. Ventilation draws smoke and heat in the stairwell between fire floor and the roof. When enclosed, secondary stairwell is used for evacuation. PPV fans should be at the bottom to pressurize the stairwell and keep smoke from entering it. You also may have fan assisted. You may have exhaust fans built into that will automatically remove the smoke, start removing it above the fire floor. And that what that does is that leaves what's below the fire floor tenable and usable. Under some conditions, elevator shafts that penetrate the roof may be used for ventilation. Do not use stairwells or elevator shafts simultaneously for evacuation and exhaust path. The exhaust path will carry heat and byproducts of combustion through the shaft, making it untenable to occupants and firefighters. Makes sense.